One of the challenges that I see today is that people in the business do not really understand AI, machine learning, the possibilities, and people in data science do not really understand the business. So I think it's wonderful, this initiative by Newton to share a little bit of the business case, so you familiarize yourself if you are not, if you don't yet have a lot of experience on the business side, so you can articulate the value that what you do can bring to the business, okay? So let's go and dive into it. So why should business leaders care about AI? And if you have attended at any Microsoft event, you know that it is mandatory to have a picture of Satya Nadella as one of the first slides. Not because it's a company policy, but the guy is truly inspiring. One of the sentences that he has in his book says that we need to build deeper empathy for our customers and their unarticulated and unmet needs. It was time to hit refresh. So he wrote this in the book, and when I read this, I said, challenge accepted, right? Because how can I, working on the customer experience area, meet the unarticulated needs that our customers have? Traditionally, customer experience is driven by feedback, by customer feedback, by surveys. So if the customer is not telling us anything, it's hard for us to figure out what to do. Then I thought, well, we have, I don't know, just going to give you a fictional number, 20% of our customers responding to our survey. We help them, we receive the feedback and do everything that we can to solve the customer problem, help them. That's fine, but what about the 80% that is not telling us anything? Those are the customers that have these unarticulated needs that obviously will get never met, right? So that was the problem that I was trying to solve. The good news is that nowadays machine learning is a piece of cake. I mentioned in the in the beginning of my career at college, we use Lisp and Prolog. If you know what a Lisp code looks like, you know what I mean. Today, there is nothing comparable to that era. It literally is just like baking a cake. And I'm going to show you how we do that. Now, what is important about machine learning to know is that, and this is one of the reactions that I hear from data scientists when they come to business. They complain that they spend 80% of their time getting data, cleaning data, querying databases, joining data, sourcing data, and only 20% of their time actually running what they like, which is machine learning. But if you come to think about it, this 20% of time that you do machine learning is actually spent 80% of the time coding, right? You have to write your R code, your Python code, or whatever is, your favorite language. And only a few lines of that code is going to be actually data science, right? So I think it's super important to have the ability to use tools like Newton to simplify that process, right? So you actually spend most of your time doing value-added work. So this is the process that I observe, right? The first and the frequently ignored step is to really understand the problem and the goals. Sometimes we jump into action and we solve a problem nicely, but that was not really the question that was asked. So the number one goal really is to understand the problem and establish a success criteria. If this is a machine learning problem, then you have to establish what is the model performance that we are looking for. right? So you set, a bar for your project so you know when you get there. If you don't have that goal, you are trying to get, I don't know, 80% accuracy, and you never get there. You're stuck at 75, and you think the project was a failure, but maybe 75% is pretty good, right? So that is something important to keep in mind. Gathering, preparing data is a necessity. In this project that I'm going to show you, I mentioned that I decided to change career and move into data science 5 years ago. I spent 3 years actually collecting data, going around the company, knocking on people's doors, asking for permission to get their data, putting that in a central database, starting running some interesting reports, nothing related to data science really yet, but just to show how data that never came together before can give us some insights that we obviously never had before, right? So that in itself is very important. And in that meantime, I couldn't stand, 3 years without producing anything. So I produced more traditional BI reports, showing this data, correlating this data that people never saw together. And we got to a point that people was instead knocking on my door, offering their data. Here's my data, connect your database, run your analysis, because I want to see how my data is affecting these other business results, right? So learn to like to deal with data. That is, I think, my best advice. Data can be good for you, right? Then explore, understand this data, clean up the data. If you are in data science and you do not understand the business, it's really hard to clean up the data because you don't know what is bad data versus good data. You can say, well, but there are some rules like outliers. But what about if the outliers is actually what the business is looking for, right? So we have to understand the context. Number 5, select the possible algorithms and tools to try. So in the next slide, I'm going to show you how you make those decisions. And then once you have the data clean and you select the algorithm, select the tool, then you have to prepare the data all over again. You have to massage that data in order to fit the tool or the algorithm that you are going to use. And depending on the algorithms, the requirements are different. You have to engineer features one way or the other. You have to split and train in test data sets. And only then you begin to actually train the model, right? And the other tedious aspect of this is that you have to start tuning all the hyperparameters. This is like, imagine a big sound table that you are in a concert, and you have all those hundreds of knobs that you can adjust the mics, the drums, etc., until you get the perfect sound. You can spend hours tuning that, right? The audio engineer can spend hours just tuning a little bit here, a little bit there, in order to get a perfect sound. And this is what also happens in machine learning, and you can spend a lot of time trying all the combinations, right? Then finally, you evaluate the performance of the model using that test data set. And that's where you're going to figure out if you have that 80% that you're looking for or 75% of the model performance. And then you repeat until the goal is met. Now, this last line, repeat until the goal is met, is interesting because sometimes you have to jump back to step 8. Sometimes you have to go back to step 6. And sometimes you have to go back to step 1, right? And renegotiate the goals. You say, well, we're not getting the 80%, but we're getting the 75%. Is that good enough? Right? And that is something important. And you are going to be in this loop for some time. So you need to find ways to save time and make this process run faster. And auto ML tools like Newton is incredible because you spend a lot less time doing the feature engineering, splitting the training the model and tuning all the hyperparameters, evaluating the performance. You can do these things a lot easier. In a traditional way, in order to do feature engineering, you have to actually write code. And you write code only to discover that that feature engineering approach did not work. So you become hesitant in creating new features, new engineered features, because you spend a lot of time to get very little reward, right? So this is another aspect that AutoML helps a lot, because from a model with, I don't know, 100 features, you can have 10,000 possible combinations of those features when you do feature engineering. If you're going to do this by hand, it's going to take forever. If you have a tool, then you can do this much more quickly. So before we jump into it, like I mentioned, you never really learn machine learning if you don't know the iris data set, right? So I'm using the iris data set in this context here, just to illustrate how important data collection is, right? Now, the iris data set, for you that don't know, is like, when you're learning the guitar, when you to play the guitar, everybody needs to learn how to play Stairway to Heaven, right? When you are doing data science, you have to learn how to deal with the iris data set. It's the same thing. So much so that, if you go to a guitar shop, you see a sign say, please do not play Stairway to Heaven, right? And when you are in a data science presentation, you go, oh, again, the iris data set. Well, anyways, the point is you have the real world, right? The real world is a picture, is an image, is an experience. And you have to figure out ways to measure that experience, measure that picture, and create data points that you can use machine learning techniques in order to process that information, right? So in this example here, if you look at enough, iris flowers, you notice that the proportion of the petal length and width, sepal length and width are very telling when it comes to the three varieties, versicolor, setosa, and virginica. So you get a little ruler and measure the petals, the sepals, the collect this data, you split into training and test data set, and then you run your model. So what Daniel is going to do is tell you how to measure the customer experience, right? It's just like looking at real life, looking at flower. How do you measure that, right? So he's going to, because we love our customers, we're telling that our customers is our flowers, right? So that is what he is going to say. And here is when in that step of the process, selecting the right tools, selecting the right algorithms, things become important. The traditional data science path is, it's deep in mathematics. You use Python, C++, C# if you're really courageous to code machine learning, right? And in the modern data science, you focus more on the business side, and you spend less time necessarily in coding and creating the models. The way that I like to explain this is like baking a cake. You can bake the cake with the raw ingredients, with the eggs, the flour, and you're making all that mess and taking your whole afternoon to make that cake. Or you can buy a cake mix. And in a few minutes, you have the cake ready to put in the oven. And, soon enough, you are having your coffee and your cake, enjoying it. Now, my grandmother would be very mad at me if I bake her a cake using an instant mix, because she is purist. She wants to see me, using the raw materials, the traditional way, etc. And I said, well, you haven't seen how fast the cake mixes have evolved these last years. It tastes delicious. It tastes just like her cake, and she is going to be completely mad at me, right? And I'm going to poke my finger at the data scientists like that. Data scientists that hesitate in using AutoML tools are behaving just like my grandmother. Okay, so that is my comparison of the modern data science with the traditional data science. And with that, let me pass the baton to Daniel.
And so when we look at a data set, as Susan had showcased, there's a lot of different things that are going on. So in this particular case, we've got our client IDs and some various different information. And so what are some of the things that a Newton can help with? So in this case, columns with 100% unique values will be dropped. So, an ID like columns, for example, columns with a constant value will be deleted. So in this case, all of these values are 1. So this isn't going to help us when we create a machine learning model. Additionally, an identical column will be dropped after scaling. So you can see that the value in column 3 is doubled value of column 2. So here you can see that the column is doubled. So this won't provide value. And then also Newton will help handle missing values. So we'll create machine learning models to fill in these missing values. Then also in different cases where Susan had highlighted, hey, in a particular column, we might have this error, right? We have somebody accidentally keyed in some letters as opposed to the numeric values. So we'll go ahead and detect those, remove them, and then predict on a new value. And then also another issue with missing values, if there are too many missing values within a particular column, if there's more than 50%, we'll just automatically drop those. And then finally, we will have rows with these different outliers or numbers that aren't fitting within the data set. So here we have these huge numbers where in the target we have maybe 5,000, but here we have a very large number. Same thing here in column 7. We have 2, 4, 6, 8. But then all of a sudden we have 10,000. So this won't be very useful for us. So we'll go ahead and jump into a live demo example. Here's a QR code to try the Newton platform for free. We have lots of different preloaded data sets in there for you to try out across different industry verticals. Today, we're going to be looking at a famous data set for predicting house prices in Boston. And so let's go ahead and jump into the platform. So this is the Newton platform. It's completely cloud-based, so you can leverage it via the web. And all of my solutions that I've created here are tile-based, and everything's on Google Cloud Platform. So all of the infrastructure is handled automatically. And all we need to do to get started is we go create new solution. In this case, I'm going to do house price prediction. So we're going to look at all of the different features within the Boston market about houses, whether they're multiple stories, how many rooms, how many square footage, and then the historical price for those houses. And then that way, as a realtor, for example, when I'm looking at new information on houses, I can take this model and then predict on what the new house price should be. And then there's some data and analytics involved as well. So once I've done that, I can either upload my data set, I can select from storage, or use a preloaded data set, which I'll do for the sake of demonstration. So here, if you, when you log in, you'll be able to get access to all of these preloaded data sets to try out the platform for free. In this case, we're going to do a house price prediction. And before I continue, I just wanted to show you kind of what the data set looks like. So here we have information about zoning, what the lot frontage is, the lot area. As you can see, we even have text data, right? So all of this is going to have to be taken care of before we create a machine learning model. As you can see, there's lots of information about the houses. And then finally, we have the historical house price of the actual value of those houses at the time. In this particular data set, we have about 1,400 different houses that we're going to learn on. So now we just hit OK. So within Newton, there's 3 easy steps for you to be able to create these powerful and predictive models. And we'll be able to look at this as well. I see some chats coming in here. I'll definitely address those at the end. So yeah, there's 3 easy steps: data set, then we train, and then ultimately we want to predict what the new house prices are. So the last step in the data set tab is we select the what we're trying to predict and train on. So in this case, we're going to want to predict what the house price is. Now the next step is training. The platform has understood that it's regression, and the metric is root mean squared log. So in this case, if we weren't using a preloaded data set, we would be able to select different task types, but for all intensive purposes, you don't need to, and then you just click training. Now what this is going to do is it's going to begin to learn on all of those. First it's going to do our automated pre-processing, which I just showcased in the PowerPoint. And then also, if you want, you can get a text notification of when the training is complete. Once it does the pre-processing and feature engineering, if you want, it'll then train a predictive model. After that, you can go ahead and start predictions. In this case, it may take a little bit of time to train the model. So what we're going to do is I've already pre-trained on this data set. So let's just take a look here. So this took about 8 minutes to train the model, and we looked at the data that was before pre-processing. Let's take a look at what it looks like now. So after the automated pre-processing, as you can see, it's actually changed all of the text into numerical values. It's filled in the missing values, etc. So that's kind of what the data will look like after the automated pre-processing. We've also baked in some analytics tools in order to help you understand the data, maybe before you do the prediction. So in this particular case, what we have here is our exploratory data analysis. We'll give you a nice snapshot of your overall data. So in this particular case, the maximum house price was $755,000, the minimum was $34,000, and the mean was about $180,000. We can see we had 1,400 rows, 81 columns, etc. In this particular case, we had about 7,000 missing values that we've been able to handle, or about 6% of our total data. In addition, we also provide what we call continuous data. So on this particular case, we're looking at the general living area distribution in relation to the target variable. So what does this mean? So within houses, right, we have a general living area. And so in this case, most of the houses fell under about 1,200 square feet for the general living area. And on the right here, on the bottom, we have our general living area, as well as the house price in the vertical. So you can actually see somewhat of a linear, actually pretty well linear relationship of the larger the general living area, the higher the house price. And you can do this with all of the different features as well. Some cases it might be informative, in some cases it might not be. We also provide information on the discrete data. So this is kind of a nice snapshot of the categorical data, if you will. So in this case, it was, did the house have central air conditioning or did it not? So 1 or a 0, or a yes or a no. In this case, a large amount of the houses did have central air, and a few didn't. And then on the right, if we look at it in relation to the target variable, we can see that quite a lot of the houses that did not have central air sold for under 180,000, and then houses with general or central air, excuse me, they sold from all the prices up to 175,000. Here, this is a violin plot. So here we can see the general distribution of the sales prices. And then all of these outliers, say some of the houses that sold for 750,000, we actually remove those automatically in the data pre-processing. We also provide a correlation heat map. This will showcase all of the features that are correlated with the target variable, as well as different features. So in this case, the overall quality of the house was highly correlated with the sales price. If we look here, we can see the first floor square footage is highly correlated with this particular feature as well. And so in this case, certain features that are highly correlated, we might want to remove. One of the other kind of cool visualizations that we have as well for your data analysis is the missing value heat map. So this is actually a snapshot of the entire Excel sheet. Anywhere there's white, there's missing values. And so here it's a little bit easier to see. So for the feature alley, you can actually see a lot of missing values, which are white. And then for some of these ones that are darker, are a lot more filled in. So we might want to say, hey, you know, we don't have much data on the alley, so maybe there's other areas we can go and collect data to fill this in to create a stronger model. And then we also show some different outliers and then the overall model quality. And in this case, we use RMSLE. And if the arrow's down, then you want a lower one. So this is pretty low, so that's good. So that's our exploratory data analysis. But of course, what we all wanted to do here is make predictions, right? Because we have all of our historical data, we had the target variable, but now we want to predict on that. So you can just click this button to enable prediction. I've already done it just to, because it takes a couple of minutes for demo purposes. You can download the solution and deploy it on a machine or on an edge device. You can also access it via REST API. So if you want to make predictions every month, you can set up and call to the cloud. And we provide the sample code that you would need to do that. So you really, you don't need to know coding. And as you can see, all I've done is a couple of clicks and I've been able to create a predictive model. No code necessary. So once you want to do predictions, you click start. And then right now, I'm going to select my test data set. So there's two data sets, the one with all of the historical data, including the sales price. And then there's all of the new data that does not include the sales price because we don't know. So now we're going to upload that and predict on it. So normally you would just click start, but I've already created predictions. And so let's see what the Newton platform has produced. So in this case, everything to the right is all of the data that we've uploaded, the new data that we want to predict on. And then everything left of this area is the new predictions that Newton has created. So in this particular case, for the first house, we've predicted this 130,000. Now, once you've done a prediction, you may want to understand, why did my model make that prediction and what are the things that I can do to help with that? So in this case, maybe we want to look at house number 4, for example. It predicted at 179,000. We can use what we've created, which is our model interpreter. This will allow you to understand the prediction from compliance purposes, or even from business outcomes. What can we do? So here we have all of the top features that are influencing the predicted value. So in this case, we predicted the house to be 179,000. Now, one of the features we have is the overall quality of the house. In this case, this house was rated as an overall quality of 6. Now, if we were to adjust the overall quality of the house to an 8, now we would predict the house would sell for 219,000. So if you think about it, as a realtor, what are the different things I can do in order to improve the overall quality of the house to ultimately get a higher sales price? And is the investment of raising the house quality from a 6 to an 8, am I able to invest, say, $10,000, right? So instead of 180,000, it'd be 190,000, but I can actually sell it for 219,000. So that's just kind of a little bit of an example of how you might be able to, look at the data, make adjustments, and then make business, actions from that.